It's a few minutes after 2 now, so I would say we start with the seminar. Welcome everyone to today's FutureEUAqua online seminar. My name is Stefan Holler. I am representing Naturland, Association for Organic Farming. I am today's host, and I will just start with a few introductory words. And before then, I will hand over to today's presenter. We will have a presentation. It will take about 45 minutes. And after that, we will have a question and answer session. And after that Q&A session, at the very end, we will send you a link for a survey in the chat box, which we would like to ask you to fill out. So let me please share my screen. So once again, welcome everybody. Before we start, just some technical points. So please turn off your audio. If you want to ask something, please take your time after the presentation. Then you can use the hand raise button, and we will take care then of your question, or you can simply type something in the chat box. So this is a little bit background about the FutureEUAqua project. It is a Horizon 2020 project with around 32 partners, or quite a large project consortium, as you can see. It was kicked off in November 2018, and we are about to ending the project. So April 2023, we will have the final conference. Yeah, as you may know, in Europe, we are still pretty much dependent on import of fish and seafood projects. We have a self-sufficiency of about only 40%, so 60% is imported. In some European countries, like in Germany, even more. We depend on 80% import, more or less. So there is definitely a demand for research and development. And the aim of the FutureEUAqua project was to effectively promote the sustainable growth of a climate change resilient, environmental friendly, organic and conventional aquaculture in Europe, and also to meet the future challenges with respect to the growing consumer demand that we have for a high quality, nutritious and responsibly produced food. So that's basically the background of the project, just in a few words. And today's topic will be Internet of Things for healthy fish and environment. May I please ask you to mute yourself? Yeah, thank you very much. The question here is, can we monitor fish patterns and traits to determine key performance indicators? And this topic will look at the impact of the housing environments and innovative diets on fish health and welfare using a wireless communication system to integrate these key performance indicators. And today's topic will be presented by Dr. Sebastien Alfonso from COISPA Tecnologia and Ricerca in Italy, Bari. So please, Sebastien, I'm going to hand over to you. I will stop my screen sharing, and we are very interested to hear your presentation.
Okay, thank you for the introduction. So I will share my screen as soon as possible. Okay. Okay. Let me know if you see my presentation correctly.
Yes, it's working. Thank you.
Okay, so let's go. Okay, so good afternoon, everybody. Thanks for the introduction. So as Stefan said, today we will see and discuss, I hope, on how Internet of Things can help to enhance aquaculture farms' productivity and ensure sustainability. And my presentation of today will be divided in different parts. First, I show you some background about aquaculture that you probably know, but it is important before entering in the detail of what is Internet of Things and how it could help in aquaculture productions. And the last part of my presentation will be dedicated to some of our results in the FutureEUAqua project, especially in the work package 5 related to Internet of Things for healthy fish and environment, and then some conclusions. So first, some background about aquaculture. So aquaculture was not born today, as you know, and started a very long time ago. And aquaculture developed over the years along the human society to reach the point we are today, and you already know. But time is continuing to pass, and things are evolving as our society is evolving. Aquaculture will also evolve. And as you know, as you can see, we are facing a huge phases of digitalization of our society. And so the aquaculture sector, we will go more and more for new technology and connection of different objects and tools together. And we will discuss that in my presentation of today. Also, as you all know, the aquaculture industry is developed a lot during the last decades, and aquaculture has become now the fastest growing food industry sectors and continue to develop to answer the demand for food and especially qualitative food. But with the development of the aquaculture there are some concerns that arise about aquaculture practices, mainly environmental and welfare concerns. Most of them are linked to the use of fish meal and fish oil into the feeds for carnivorous fish species, but there are also concerns related to fish escapes or antimicrobial use in aquaculture industry. And there are also some welfare concerns related to stocking density or water quality, for instance. But these concerns may affect, in one side, fish production, but can also affect consumer opinion about aquaculture industries. And this may lead to negative economic consequences for farmers. So it is in that context that the FutureEUAqua project, which Stefan already introduced before, it's a big consortium that include research institute, association, and aquaculture farmers. So bringing a really large range of partners. And the main objectives of the project are to effectively promote the sustainable growth of environmentally friendly aquaculture in Europe to meet the future challenges of our modern society. And in the context of the project, COISPA, we are mainly working in the work package 5, which is named Internet of Things for Healthy Fish and Environment, which is led by Giuseppe Lembo from COISPA. And our main work and task is to monitor the impact of housing environments and innovative diets on the fish health and welfare during large-scale demonstration activities. And also we are doing that by using a wireless communication system to integrate key performance indicators. And our main tasks are related to the enhancement of fish health and welfare, environment sustainability, and production. But before speaking about the result of the project in the work package, I will show you first and explain what is Internet of Things and what kind of tools can be used in aquaculture. So first, what is Internet of Things? Internet of Things can be defined as a network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables this object to collect and exchange data together. And in FutureEUAqua project, we are using this connection between different objects in the framework of aquaculture. But before speaking about aquaculture, some few other words about Internet of Things in our daily life. Where are we using Internet of Things? Some example can be related to home security. For example, you may have some sensor at your home, which are connected with alarms, camera, and light. And if you are one issue in at your home, sensor can catch it, switch on alarms, camera, and you may be far away from your home and have a notification on your cell phone and see in real time what is happening. There are also different use, mainly for health monitoring, which activity trackers that are monitoring fatigue, appetite, blood pressure, or heart rate, for example. And let's say that 10 years ago, this technology was only for medical things. Today, it is possible to everybody to get access of such kind of technology. So it's evolving very, very fast. And the Internet of Things has unlimited possibilities. And what is really important to keep in mind is that the Internet of Things is really just getting started. And years from now, we will be connected in ways that are difficult to imagine today. IoT application, especially when combined with artificial intelligence and automation, will improve decision-making, efficiency, convenience, wellness, and energy conservation. We saw it a few months ago with the software, the chat with artificial intelligence, ChatGPT. Everybody was shocked, etc. But what about in 10 years in the future with the use of such software in other application? It will be very, very interesting in the future. And so the integration of these technologies will also enable creative thinking and innovative application across a wide range of industries, including in aquaculture, that we will say in the presentation. So some tools to be used in aquaculture, or some things. First, for monitoring fish health and welfare. We have first accelerometer tags that are sensor like that, which are measuring fish acceleration, which is related to fish energy expenditure. Also, you have other sensors that are measuring heartbeat rate. So, and such measurements are related to stress state of fish. You have other sensors that can measure muscle activity. So you can know exactly, you have some insight more specifically into aerobic or anaerobic metabolism. And more simply, you have camera systems that you can follow fish behavior, so also swimming activity, position into the fish tank or cages, and also fish interaction between individuals. You have also other tools related, for instance, for estimated biomass, and those are working with different technology. For instance, you can have some tools that are working with acoustic transmission, infrared technologies, or video cameras, as we will later see in my presentation. But how these tools can help in aquaculture to enhance environmental sustainability, fish welfare, and productivity. Okay. In addition to some tools for measuring health and welfare, for instance, you may have also other sensors that can monitor environmental parameters, such oxygen, concentration, temperature, salinity, blue or green algae concentration, turbidity, etc. And those sensors may collect data and send it to a cloud, and then you may have access to the data in real time. And so know exactly what is going on in real time and adapt a decision if needed. We will see later more detail as part of the results of the project, and how this could help to enhance sustainability and production. By controlling in real-time environmental quality, as I said, you can take fast decision to prevent any health and welfare issue, and so do not have some negative effect on production. Other tools that can be used are related to biomass estimation, as I said, and what is interesting to have biomass data in real time. So it is really important because you have a constant monitoring of fish growth, which is very important for farmers to adapt feed quantity, etc. And also it helps because it avoids to sample some fish to get this data. Also, you have other tools and systems that are currently developed, which are looking to the detection of satiation. And this is very important also to avoid to lose feed. And so they will increase the productivity of farmers. And also from environmental point of view, it is very interesting because by avoiding to losing feed, it is also nice for environmental point of view. I will show you quickly a video, just a minute, which is a summary of what I explained. And it is, I think, very nice to understand how it could work. Do you see the video? Yes?
Yes, it's working.
Okay. Okay, so I hope you enjoyed this video. And yeah, it's a really good summary to understand different possibility, different combination of sensors and how we can use it in aquaculture. So let me go back to the presentation. I think it is working.
Yeah, it's working. Sebastien, please go ahead.
Thank you. So I am going ahead. So, but it is very nice and it will be very nice in the future. But today there are some limits that we are working to face as soon as possible. Just some example. And for instance, you may have use this situation if you are when you are monitoring the oxygen concentration, sorry, in your cage or tank, and when the level drops off, you may have an alarm and oxygen is supplemented into water to increase the level. But when you are monitoring a different parameter, which is the case in when we are using Internet of Things and different kind of sensor, for instance, when you are monitoring oxygen concentration, growth performances, fish swimming activity, you will have a lot of signal, and sometimes it is difficult to understand what is going on, and especially what is very important and interesting for the future is to use algorithms and machine learning to detect early point, identify early point before any welfare or health issue happens in tanks. So you may act quickly to avoid those welfare issue and enhance fish production. And in the future, it will be very, very useful to use such system in aquaculture. But some other limitation, it's sometimes the price, because such sensors are quite expensive, still expensive, depending on the size of farm, and some farmers don't want to pay so much for the sensors. But it is important to emphasize that technology is evolving very fast, and I think in the future years, the price will be lowered a lot. And also we need times to develop different tools, because some of them are species specific. For instance, for biomass estimation system, it is not the same if you are working with sea bass or sea bream, because the algorithm and calculation should be different, because the shape of fish are different. So there is still times for develop Internet of Things. But we are working a lot. Research institute in collaboration with farmers are developing more and more sensors, try to find best solution to reach low-cost sensors. And so in the future, it will be better. And as I said before, it's really nice that researcher and farmer collaborate together. For instance, in the FutureEUAqua, it is very, very nice that we collaborate with farmers to be able to find the most efficient solution for them at a lower cost. And I thank them very much for their help and availability for working on such research projects. So here we are. I will show you now in the last part of my presentation the sum of the results we had in FutureEUAqua projects. First, I will focus on the calibration of physiological sensors that we had in laboratory, to then use those physiological sensors for health and welfare monitoring purposes in large-scale trials. And then I will show you some results on the use of sensor during the large-scale trial, and also how we can connect the physiological sensors with environmental ones to have an overview of what's going on in the farm and how these sensors could help to predict growth performances and mortality of fish. So, as I said briefly, this work is part of one package 5 of the FutureEUAqua project, and it is related to Internet of Things for healthy fish and environments. So first part was the calibration of physiological sensors. To be brief, this first step of research was done to calibrate the acceleration recorded by sensor, so accelerometer tags, with energetic features such as oxygen consumption rate, MO2, and muscle activity. And then use the acceleration recorded by the sensor as a tool and a proxy of energy expenditure for welfare monitoring in free swimming fish during the large-scale experiments. And so this calibration step was done in a laboratory, so in swimming tunnels, and we estimate metabolic rate during euclid trials, and we calibrate the oxygen consumption rate with acceleration of recorded by tag. And we also did some measurement of red and white muscle activity using electromyographic technology. And we did the calibration in the different targeted species of the project, which are relevant for European aquaculture, which are sea bream, sea bass, trout, and salmon. And I will show you some calibration on sea bream and sea bass. So what we did is that we implanted the fish with accelerometer tag into body cavity. During the calibration step, the size of sensor was more or less 4 centimeters. But now it is possible to have a smaller sensor like this, which are 3 centimeters long. And we use this kind of sensor during large-scale trials, so one of 3 centimeters. And so in swimming tunnel, we can increase slowly the swimming speed of the water flow. And then we are recording, we are measuring the acceleration from sensors. And we can see that it responds very well to the increase of water flow in the swimming trial. And our objective during this calibration work was to correlate the swimming activity, so the acceleration recorded by sensors, with the oxygen consumption rate to have a proxy of energy expenditure. And this as a calibration curve for sea bream and sea bass, but we also did for rainbow trout and for Atlantic salmon. And also what we did, we also measure the activity of red and white muscle, which are related to aerobic and anaerobic metabolism respectively. And briefly, what we can observe, it is at low speed, for instance, 0.1 meter per second or 0.4, the red muscle take care of to fuel energy to the organism, while at higher speed of, for instance, 0.8 meter per second, there are also the contribution of white muscle, so the aerobic metabolism. And we modeled the activation pattern of both red and white muscle during the UQ trial to be able to correlate the acceleration recorded by tag to the different contribution of aerobic and anaerobic metabolism. And this could be also used during the large-scale trials that I will show you and discuss in the following slides. So just to conclude about the calibration work, as I said, calibrating the acceleration recorded by accelerometer tag with oxygen consumption rate and red-white muscle activity allow us to use the acceleration recorded by the sensor as a reliable proxy of fish energy expenditure, referring especially to aerobic and anaerobic metabolism. And then, which is very interesting for us and for the future, is that such sensor will be used for remote health and welfare monitoring purposes in aquaculture context, in the framework of the project, but also in the framework of future research project, and we hope also in the industry. And if you are interested, we publish some paper about the calibration work, so please feel free to go for more details. So then how we are using the sensor in aquaculture facilities. I will show you only one example during the large-scale trial testing the innovative diets of the project. In the case, a conventional diet in sea bass. And this trial took place at Pyros in Greece, in the facility of Avrama, which we collaborate during in 2001. And during this trial, in addition to classical blood sampling for stress, health, and welfare parameters, cortisol, glucose, lactate, hematocrit, hemoglobin, we also implanted some fish with accelerometer tag, which allowed to have a continuous monitoring of acceleration. And so a proxy of energy expenditure over the trial. And what are the results regarding tank? What kind of data we can have? First, of course, you can have the mean acceleration for each fish implanted during the trial. And also you may have a mean acceleration to compare between the two diets. But in the case of this trial, we did not see significant difference between the two diets, even if there is a tendency. But if we are looking in much detail to the data provided by TAG, we can first have, as I said, a continuous monitoring over time. So it is very interesting because you can assess specific stress during a specific period of time. Maybe it can be correlated to change in environmental parameters or management practices. So it is very, very interesting to use sensor for such purpose. But also you can have other insights when you are looking to the frequency distribution of the data. For instance, in this experiment, we observe that for low and medium value of swimming activity value, there was higher quantity of data for fish-fed innovative diets than conventional ones, which is suggesting an higher contribution of aerobic metabolism, while we saw opposite results for high swimming activity value with fish-fed conventional diet displaying higher quantity of data of high swimming activity value, which suggests higher use of anaerobic metabolism. Also, we can use the acceleration recorded by TAG with the other parameter, more classical parameter for measuring stress, health and welfare, cortisol, growth performances, lactate concentration. And this will help to have a larger and more comprehensive overview of health welfare state of fish, because you have, as I said before, a continuous monitoring of fish. So to conclude about this experiment, how tags could be, such sensor could be interesting for monitoring health and welfare in aquaculture. We show that the swimming activity allow the continuous health and welfare remote monitoring, especially by estimating the energy expenditure linked to aerobic and or anaerobic metabolism. Which was very important, but I did not show you data, is that tagging did not affect significantly health and welfare of fish. Also, we measure high survival of tagged fish during the experiment, so 29 out of the 30 tagged fish. And this is supporting the use of such physiological sensor for welfare monitoring in aquaculture. And also, which is very interesting, is that the insights gathered from TAG can be combined to other more classical health and welfare parameters to have a larger overview of health and welfare state of fish. And finally, Alfonso, I only presented the result of large-scale trial in sea bass. The tags were also used in the large-scale trials for sea bass, for sea bream and rainbow trout. And we had also very nice result from tag use. And if you are interested, you can access soon to the deliverable D5.5 of the project. And finally, the last part of the project, I will show you some results on the biomass estimation system that was developed by colleagues from the University of Thessaly. And briefly, the aim of that task was to develop a low-cost system being able to estimate biomass in cages. And so they use low-cost camera and open source software to do that. Just some slide to explain their approach. As for us, they did some measurement into lab scale to be able to estimate the size of fish using different images. And what was very important is that the lab's preliminary test was very sensitive, and the measurement error across multiple tests was more or less 1 or 2%, which is very, very nice to have an estimation of fish size and so mass. And so 2 years ago, they also test in large-scale trial in Kefalonia fisheries, the camera, and they also analyze the data, and they finish the compilation of the deliverable D5.7. And so you will be able to access the result of the biomass estimation tools, which is very promising for the future. I think for the farming industry, such tools will be very, very interesting. And so we are going to the last experiment we did always in Kefalonia fisheries facility in Greece. So in that experiment, what we did is that we monitor fish and environment for 4 months, and colleagues, farmer colleagues, took some morphometrics measurement along the period and also recorded mortality. And so we will have both growth performances and mortality data, and we will try to predict those data based on physiological and environmental sensor that we also implemented into the farm. So as for the other trial with Avrama, we implanted some seabass with accelerometer tags. And in addition to that, we also implemented some environmental sensors into the sea cages. Those sensors measured oxygen concentration, temperature, salinity, and turbidity. And what we did, which is very important, is to have the data in real time. And so what we did is that we had a receiver near the cages. It was 200 meters, but we can go until 500 meters. And both physiological and environmental sensors are sending data acoustically to a receiver, which is connected to a hub powered by a solar panel. And the hub will send data to the farmer to get the data in real time about fish behavior, physiology, but also about environmental parameters. And it is what we have in this slide. So in the first picture on the right, named A, you can see that you can follow the behavior of each fish. We can have data on a vertical position, but also on its acceleration over times. I think, if I remember well, you can have data each 1 or 2 minutes. And also for the sensor, you have information about oxygen concentration, turbidity, etc. And you can follow that in real time. And okay. And what we did is that after 4 months of monitoring, we analyze the data. So of course, you can monitor the swimming activity patterns over time, also with day-night alteration. You can also monitor behavior, so depth of fish during day, night, etc. But what was very interesting during this experiment was to predict the weight gain by fish using the data from physiological data and environmental data. And we were able with the data from sensor to predict growth of fish, as well as mortality during the trial. I did not go in too much detail about those models, but I just want to show you the figure and to say that it was possible. And to conclude about this last experiment, so as I said in a previous slide, so as we show in the project, it is possible to predict growth performances and mortality of sea bass using physiological and environmental parameters recorded using a wireless sensor system. And this is very promising for the future. It is, however, important to note that models and prediction have to be enhanced by including more parameters, such as species, salinity, turbidity, water current, and mass. Because as you see in that experiment, it is only 4 months of monitoring in sea bass. So if you want to have a more reliable and models, you have to increase the duration of monitoring in different season, places with different salinity, oxygen concentration, etc. So in the future, after a huge phases of work, we will be able to have very nice forecast based on different sensors. So to conclude briefly about the use of Internet of Things for enhancing fish health, welfare, and production. So we saw that real-time wireless communication system may help to enhance water quality, for instance, by monitoring continuously water quality and feeding of fish to avoid to waste some feed, etc. But it will also help for fish and welfare monitoring, mainly using physiological sensor and monitoring fish stress state and adapt aquaculture practices. And both by monitoring water quality and fish health and welfare, this may help to maximize the production for farmers. And all of that will help in the future to enhance economic gains for farmers and also to the environment in order to enhance sustainability of European aquaculture. And so finally, to conclude, I hope in the future, Internet of Things will help to improve precision and efficiency of work. For sure, it will be the case. And as I said at the beginning of my presentation, IoT is being developed fast in all sectors, including aquaculture. So work is ongoing as we did in the project, and also in the future, there is also other work that will be done to improve algorithms to early detect health and welfare issue, improve biomass estimation system, and fish behavior. And which is very nice also, it's that the European Union finances projects involving both scientists and aquaculture industry to develop the aquaculture of tomorrow, which will be for sure more sustainable and environment friendly. So to finish, I will say once again, it is important to keep in mind that the Internet of Things is really just getting started. Okay, and I will also have a last video, which is a 5-minute video, which is summarizing our work in FutureEUAqua project on Internet of Things and how use physiological and environmental sensor in aquaculture. I think it will be just on time to show you today, but you will have the link and you can access later if you are interested in that topic. And okay, I will conclude by big thanks to different colleagues involved in the project, and mainly l'Istituto Profilattico Sperimentale delle Venezie, l'University of Thessaly in Greece, and also the aquaculture industry's partners, Avrama, Kefalonia, that allow us to work in collaboration with them on the development of sensor during the project, and also Asa for coordination, and Stefan for the organization of webinar. So thank you for your attention. I hope it was not too long. And yeah, I am waiting for a question now. Thank you. Yeah, Stefan.
Yes, thank you very much, Sebastien. That was highly interesting. Of course, this Internet of Things is a yeah, really sophisticated technological development with lots of potentials, and obviously with a lot of potential also to support the aquaculture industry. So it was very interesting to see concretely how Internet of Things can be integrated and support the aquaculture operators. So thanks again for that.
Thank you.
So now it's time for questions and answers, and let me have a look at the chat. I can see Michelle already asked a question with, yeah, that's definitely something which can be asked in that context. I'm just reading the question. Using tags and inserting sensors into fish to monitor fish welfare sounds interesting, but also somewhat ironic. You know, obviously you interfere in that fish to measure the welfare. Are there sensors, for example, cameras and artificial intelligence, which could monitor fish welfare through non-invasive technology? And then also she says, for example, are there cameras which can monitor the acceleration rather than having to tag insert? So yeah, did you somehow measure the animal welfare is affected by these tagging, and are there maybe alternatives where you don't have to interfere into the fish?
Okay, thank you for the question. Yes, so it is a question that we have a lot about use of sensor relating for measuring welfare, and how are we sure that sensor don't affect welfare. So what I can to say is that a lot of work have been done before the project and also during the project to check and assess how the implementation of sensor are affecting fish welfare. And what we observe in sea bass, sea bream, trout, and also the last result of salmons were out some week ago, we saw that it did not affect too much fish welfare. For instance, we monitor stress markers, cortisol, glucose, lactate, but also welfare scores after implantation over more or less long period of time. And we did not see a lot of negative aspect of tag implantation first. And then the second question was related to use of camera as a camera which can monitor the accelerations rather than having to tag insert. So I know that there are some studies that try to use camera for monitoring acceleration instead of tags. I know it may be possible, but what I'm not sure that if the acceleration recorded by camera is really linked to energy expenditure. For that, I'm not sure that today is it possible, but maybe in the future it will be also possible. There are different ways to work.
Michelle, does this somehow answer your question, or you want to add something?
Thanks. Yes, it does. I can just still sort of anticipate that, okay, scientifically the harm is maybe insignificant. I still think consumers will react differently, whether it's significant or not. I think some consumers will just not like the idea that the fish they eat had something inserted, a chip inserted or something. And so I'm just wondering, that I was just asking, are there alternatives? And maybe my follow-up question is, you were presenting the research, but what do you anticipate in a real life example? Would it be a handful of fish that have these tags and inserted sensors to monitor the entire stock in all the cages, or would it actually be that 100% of the fish have tags? That wasn't clear to me.
No. It is not possible to implant all the fish, first because of the cost of such sensors, and also for practical reason it is not possible. So what we can do is implant a small percentage of the fish stock, but what we show and so during the project is that there is not too much variability between the different individuals, so we can think that a small sample is enough to be representative of the large population. And also the fact that as we observed, it did not impact so much welfare of fish, so we can be confident that it is a reliable marker for health and welfare monitoring. I don't know if it is answer your question.
Sorry, guys, may I add something to what Sebastien said just now?
Pino,
Yes.
go ahead. Yes, please.
Okay, I'm Pino Lembo speaking. Yes, the question from Michelle is very, very interesting, and I would like just to add that maybe, as Sebastien said, in the near future, we will have much more information from system using a camera. But what is important to underline is that the acceleration in itself doesn't say nothing of interesting for us. What is important in the work that we did is that we made a calibration between the acceleration and the oxygen consumption. So we got specific metabolic measure, which are the only indicator that can say to us something about the fish welfare. So currently, this is the only way to get very precise measure about the fish welfare. And as Sebastien said, we don't need to tag, to implant many fish, because it is really useful to tag a very small fraction of the population in order to infer the results for all the population. And the last consideration that come in my mind is that this kind of technology and methodology just we got from the human medicine, because it is not different from what currently happen when you for example, human are implanted with a pacemaker, and this is actually well accepted by the population. There is no real difference among the different use that we do of this sensor, like in human. And also the surgical procedure are very, very simple and do not have a very important drawback for the health of the fish. That's all for me.
Yeah, thank you very much, Pino, for adding this information. Anyone else? So this is time for your questions now. I'm not sure, I might not be able to see when you raise your hand, so I would just like to ask you to speak out directly or write your question into the chat box.
if no one else has a question, I'll just speak up again. Can you give us any sort of cost indication? I know this is research and not how it would then work on a farm, but what would the cost of an individual sensor be, and what would the cost be to actually use it, run it, have someone know you know, how to use it and interpret the results? Can you put any figure on that?
Yes, do you mean the cost of physiological sensor, right?
Yeah, or any of the ones you presented. Yeah, if
Okay.
somebody wants to use it to monitor welfare or to increase productivity, can you put some sort of figure on that? A salmon farm with 5 cages, what would that be?
Okay, it depends a lot of how many things you want, etc. But I will try to get you some tags, some information to have an idea. So the price of tags, it depends also a lot of the feature you want, but you may expect one tags for between 6 months and 1 year of monitoring. It's around 600 and 800 euros, depending on the features. For environmental sensor, also it depends of what kind of environmental parameters you want to monitor, but it's between 1,000 and 2,000 euros if I am good. Pino can confirm later. And if you want to put everything have data in real time, you also need to consider a bit more to buy the hub. It's more than 3,000 to 4,000 euros, I think. Pino may confirm if it's those kind of price.
Sorry, but it is really difficult to be precise because the cost may vary a lot according to the different feature of the aquaculture farm and what you want to have. And at the end, the matter is to find the trade-off among the different possibility and what are the expenses that any farm can afford. So the figure that you give are very rough idea. Then for entering in much detail needs to to know better which are the feature of the farm and the objective of the farmer.
But if you can share with us the feature you have in mind, we can discuss in more detail for sure later. Bye.
Thank you.
Okay, yeah, thank you very much. So I do not see any more questions. So before closing, let me just please share my screen again. Yeah, this is just to invite you for our next seminar. So the next one will be on 14th of March. It's about quality and safety of aquaculture products from University of Bologna. And then we will also have another seminar, sustainable and resilient production systems, from Wout Ebbing, that had to be cancelled. So we still not determined a date for that seminar, but we will keep you informed. And here on the website you will find some more information, and also in the chat box Emanuele has put a link to a survey form. So we would be really grateful if you just take a few minutes and fill out these 5 questions, or how many there are. I think it's 4 or 5 questions that will give us an important feedback and will be very relevant for our final project report. So once again, Sebastien, thank you very much for your presentation. Thank you very much, dear audience, for your attention, and hope to see you next time.
Thank you.